All right, the next question is a double integral. So notice that in this double integral, if you try to integrate with respect to x first, like it kind of like we're supposed to do according to the order of integration, then we won't really be able to do it because you can't find the integral of sine of x squared in closed form, right? So which means that we need to switch the order of integration and then do the integration. All right, so here is the integral. It's from 0 to 1 and from 0 from y to cube root of y pi times sine of x squared pi dx dy. Well, to switch the order of integration, we need to draw the sketch the region of integration. So I guess everything happens in the first quadrant, so both x and y are positive. Y varies from 0 to 1, right? So this is 0, this is 1, so y is between the x-axis and the line y equals 1. Now, the lower boundary for x is y, right? So here is the line y equals x. And our region of integration is on the right of that, right? So because this is the smallest possible value of x, right? So, and the largest possible values of x, so let me write it. So x is between y and cube root of y. So the largest possible value of x comes from this inequality, so it is going to be cube root of y. And of course, if x is cube root of y, then y equals x cubed, right? So the line y equals x cubed, this is what it looks like. It's a cubic parabola. And basically, x changes from this to this, right? So here is the region of integration. All right, so now we've got to turn it over. So we've got to now look at how x is changing. So notice that at this point is really just 1, 1, right? Because at this point, y equals x, and at the same time, y equals 1. So x is also 1. Okay, so which means that the smallest possible value of x is 0, and the largest is 1. So x is from 0 to 1. And now y. So now the smallest possible value of y, so it's like minimum y, is here, and it is on our cubic parabola, so it is x cubed, and the largest value of y is here, right? So this is like maximum y, and it's just y equals x, so the integral is from x cubed to x. Then we have our pi times sine x squared pi dy dx. All right, so now how do we solve this integral? So the first is we do the inside integration. So notice that here we're integrating with respect to y, but the function doesn't really depend on y, so we can just take it out. So this is going to be just x minus x cubed times pi times sine of pi x squared. And we've got to integrate this expression with respect to x. Okay, so I guess I can take out x. I don't know, this is from 0 to 1. 1 minus x squared times pi x. So I took out x from here. Times sine of pi of x squared dx. And then I guess I can do a u substitution. So u is whatever is inside the sign. It's just convenient to do a u substitution here. So pi x squared. In that case, du is going to be 2 pi x dx, right? And we kind of have it here. So there is pi x and dx. So I guess we can just rewrite it as the integral. Okay, so we have pi x dx, and du is twice that, right? So we have to divide by 2. So it's 1/2 of the integral from 0 to 1. Then 1 minus x squared is really u over pi. All right, so then pi x dx over 2 is our du. So then we have sine u du. Now this integral can be done by parts, but I'm not going to bore you with this because it's a routine calculation, so I will just do it in Wolfram alpha, right? So here is 1/2 times the integral from 0 to pi of, I believe this is the correct integral, so, and the answer is just 1/2. All right, so the answer here is 1.